Introduction to the history of machine learning. Will the day come when machines learn and unlearn on their own? Perhaps that time has already arrived. Machine learning is grounded, in part, on a model of brain-cell interaction. The model was created in 1949 by Donald Hebb in a book entitled The Organization of Behavior. Lately, it was defined by Stanford University as the wisdom of getting computers to act without being explicitly programmed. In 1967, the KNN nearest neighbor algorithm was cooked, which was a morning of introductory pattern recognition. This algorithm was used to collude routes and was one of the first algorithms used to find a result to the traveling salesperson problem to find the most effective route. The boosting algorithm is used to reduce bias during supervised learning and includes machine learning algorithms that transfigure weak learners into strong learners. Machine learning is a branch of artificial intelligence that houses different styles or algorithms that are necessary to automatically produce models from a set of data. While an unequivocal rule-grounded system will perform a task the same way every time, the performance of a machine learning system can be bettered through training and by exposing the algorithm to further data. Machine learning algorithms are divided into supervised and unsupervised. In the former, the training data is related to the responses. This type of algorithms are used to break bracket problems. In unsupervised algorithms, they don't have the connections with the responses, so they're generally used for analysis. The problems in which it's used, thus, are of the associative type, clustering that allows us to search for analogous objects from a larger group and dimensionality reduction. Machine learning relies on a series of algorithms to convert a dataset into a model. The choice of algorithm to perform this task must be grounded on three abecedarian bases: the quantum of coffers available, the type of data to be used and the type of problem to be answered. The most common algorithms in machine learning are 1. Bracket algorithms 2. Retrogression algorithms 3. Clustering algorithms 4. Dimensionality reduction algorithms 5. Grade descent. In feed-forward networks, all neurons are organized in different layers. The first of these is the input subcase, where the data to be reused is entered, followed by an indeterminate number of retired layers where the processing is performed and, eventually, an infer subcase. Another important specific of this type of network is that the processing is performed in only one direction, which is different from intermittent neural networks, which can take information from former inputs and therefore impact the current input and infer. The convolutional neural network is a special type of neural network that is, as we will see laterally, especially effective in image recognition and bracket. Because of this, they are extensively used in arenas that bear the identification of objects, faces in business science, as well as being an abecedarian part for independent buses and robots as they allow them to dissect and structure all the objects around them. Natural language processing (NLP) is another major operation area for deep learning that gives computers the capability to read, understand and interpret mortal language. It helps them hand sentiment and determine which corridor of mortal language are important. Underpinning learning trains an actor or agent to respond to terrain in a way that maximizes some value, generally by trial and error. This is different from supervised and unsupervised learning, but is frequently combined with them. In creating a deep learning model, generally the first step is to clean and condition the data, followed by point engineering, and also testing any machine learning algorithms that make sense. For certain classes of problems, similar as vision and natural language processing, the algorithms that are likely to work involve deep learning. Fundamentals of machine learning. The basics of machine learning are the keys to success in any artificial intelligence project, virtual reality, metaverse or any new robotic technology. A learning process is successful if its vaticination or estimation improves with adding data. Thus, the notion of success of the learning process requires a fine treatment of the error and price rate in relation to the complexity of the problem. Machine learning, thus, improves performance with adding empirical data volume. In machine learning we use fine statistics to model deficient information and the arbitrary nature of the observed data, i.e., we make fine and /or statistical models for problems whose results are learning algorithms. To make fine models for problems in machine learning, we need to specify the type of problem we want to break and the type of data available, which results in the type of machine learning model, which we also call the type of machine learning. A programming language is a computer language that programmers use to develop software programs, scripts or other sets of instructions for computers to execute. There are a multitude of different programming languages, although these can be organized according to what they're intended for or how they do. Let's look at some of these groups. 1. Procedural programming languages. 2. Functional programming languages. 3. Object-acquainted programming languages. 4. Scripting programming languages. 5. Sense programming languages. Some of the most important programming languages in machine learning are Python, R, Java, Lisp, JavaScript, Prolog. Python is a general-purpose programming language, so it can be used for numerous effects. Python is used for machine learning, but also for web development, AI, operating systems, mobile operation development and videotape games. Successor to the ABC programming language, Python is a high-position, stoutly compartmented language developed by Guido van Rossum in the early 1980s. In recent times, Python has come a fave of the technology assiduity, and has been used in a wide variety of disciplines. Python is frequently compared to Perl, Ruby, PHP, Scheme and Java. This is because it's an incredibly important object-acquainted language. Machine learning applications in the entertainment, commercial and industrial fields. Let's take a look at the main industries that will benefit from machine learning advances and the benefits and advantages that this will provide. Image recognition is a technology that's grounded on the capability of software to identify people, places, everyday objects or indeed places grounded on their terrain. Image recognition is just one part of what's called computer vision, which encompasses numerous other effects in its practical side, similar as videotape object shadowing, image reconstruction or discovery and isolation of different events. On its further specialized side, computer vision includes the different styles of collecting information, assaying this information and processing it. The most effective tool planned for the task of image recognition is the convolutional neural networks CNN. CNN is an armature designed to efficiently reuse, relate and understand a large quantum of data in the form of high-resolution images. Traditional neural networks use a completely connected armature where each neuron in one subcase is connected to all neurons in the coming subcase. Still, this completely connected armature is hamstrung when it comes to recycling image data for three main reasons. 1. For an average image with hundreds of pixels and 3 channels, a traditional neural network will induce millions of parameters, which can lead to overfitting. 2. The model will be veritably computationally ferocious. 3. It may be delicate to interpret the results, remedy and tune the model to ameliorate its performance. Sentiment analysis or opinion mining uses natural language processing (NPL) and machine learning to interpret and classify feelings and private data. Sentiment analysis is frequently used in companies to describe different opinions on social networks, measure a brand's character and understand guests. Automatic analysis of client feedback, similar as opinions and check responses and exchanges on social networks, allows brands to hear precisely to their guests and acclimatize products and services to meet their requirements. Main types of sentiment analysis in machine learning. 1. Detailed sentiment analysis. 2. Emotion discovery. 3. Aspect-grounded sentiment analysis. Artificial intelligence technologies, similar as machine learning and deep learning, can do the monotonous and heavy lifting of non-stop monitoring that no human could do in the same quantum of time. In this way, they become intelligent eyes and cognizance that can warn, in real time, law enforcement to take action that can help crime. In a public safety terrain, AI capabilities, programmed by humans and trained over time, could dissect thousands of videotape feeds to track and alert authorities to anomalies. Current videotape sources that AI could dissect include, precisely, those from CCTV, home videotape cameras, security services and smart cinches among others. The results attained in the prognostications depend basically on the input data that we give, so if this work isn't done duly, the prognostications of the algorithms won't be correct, losing all that competitive advantage, or indeed, occasionally, can have serious damage to the company. Microsoft's Project Inter-Eye is an illustration of the operation of machine learning styles for the segmentation and identification of excrescences using 3D radiological images. Similar operations can be extensively salutary when planning surgery or radiotherapy, or for covering excrescence progression. AI and data association ways allow us to uniquely address some of the most common problems in the healthcare system: long waiting lists, huge bills in countries without a free public healthcare system, complex paperwork, or not having access to the right healthcare professional. Machine learning takes the client touchpoint, tracks exertion in real time, and predicts a coming stylish action grounded on stoner exertion. Machine learning predicts druggies' future needs grounded on history, performing an upsell and cross-sell openings. The system indeed triggers hyperactive individualized announcements to partake with the client, while the client is still on the call, similar as new products or service offers, because the client in question searched for that particular keyword in the history. DLSS, or Deep Learning Supersampling, is a fashion for intelligent scaling created by NVIDIA, which can take an image rendered at a lower resolution and rescale it to an advanced resolution, therefore furnishing further performance than native picture. NVIDIA introduced this fashion with the first generation of the RTX series of its plates cards, a chief in the generation of videotape game plates. DLSS isn't just a fashion for upscaling or supersampling, but uses AI to intelligently increase the quality of the image that was rendered at a lower resolution to save image quality.